Hi everyone, this is Ms. Shea. In this video, we are looking at functional groups. Now this is part one of two videos on functional groups. In this first video, we're just going to talk about what functional groups are and go over the hydrocarbon functional groups, and then look at four of the more common functional groups. And we'll leave the other functional groups to the next video. So what are functional groups? A functional group is a group of atoms in organic molecules that are responsible for the characteristic chemical reactions of those molecules. Now, compounds that contain a certain functional group are put together in a class of compounds, and we have a name for that class. The functional group itself has a different name. And then when we name these compounds, we use a different suffix. And so as we continue on, you will see what I mean by that. So we'll start with the hydrocarbon functional groups. The first hydrocarbon functional group is the alkyl group, which is simply the single bond between a carbon and the next carbon. So a compound that contains only single bonds between all the carbons is an alkane. And an alkane's name always ends with the suffix -ane. For example, propane. The next hydrocarbon functional group is the alkenyl group. The alkenyl group is a double bond between two carbons. A compound that contains an alkenyl group is classified as an alkene. And alkenes are all named with a suffix -ene. The next hydrocarbon functional group is the alkynyl group. The alkynyl group is a triple bond between two carbons. And a compound that has an alkynyl group would be classified as an alkyne. And all alkynes are named with the suffix -ine. So let's look at a few examples from your guided practice packet. This is number 7. Here we can see that there is a double bond between these two carbons. So there's our alkenyl group. So this is an alkene. And since there are only two carbons in this alkene, we would use the prefix -eth for two carbons. So this would be called ethene. Number 8. We got an alkenyl group right there. And there are 4 carbons. So this is an alkene, and with alkenes that have more than 3 carbons, we need to number the carbons so that we can tell where the alkenyl group is. In this case, the way that we should number this is from the left to the right, so that the alkenyl group will get the lowest number. Now, since there are 4 carbons, the prefix would be but. So we would name this compound but-1-ene. Moving on to number 9. In number 9, we got another alkenyl group. And just like with number 8, there are 4 carbons. However, the alkenyl group is now on carbon 2. Now notice we can number the carbons from the left to the right, or I can number them from the right to the left, like what I'm doing here in blue, and that alkenyl group will always be on carbon 2. So we would call this but-2-ene. Now, another thing that we need to make note of here is that the double bond actually locks everything that's attached to those two atoms in place. And so the 2 hydrogens, notice that they are on the same side of the double bond. And so we would actually call this a cis-but-2-ene. We can also have a trans-but-2-ene, and I'll draw it down here. So if we have a trans-but-2-ene, then what we would see is the hydrogens will be on opposite sides, and carbon 1 and carbon 4 would also be on opposite sides. Okay, so this is trans but 2-ene. Moving on to number 10, we can see that we have another alkene. There's the alkynyl group. If we number the carbons from the right to the left, then the alkynyl group will get the lowest number. I can number the carbons from the left to the right, like I'm doing here in blue, and we'll see that that alkynyl group will get a higher number that way. So we need to go with the red numbering. Now, there are 5 carbons, so we will use the prefix pent, and since the hydrogens, where the alkynyl group is, are on opposite sides, this is called trans pent 2-ene. Moving on to number 11, we have an alkynyl group, and there are 3 carbons, so we would call this compound propyne. Now we actually don't have to number the carbons in this case because there's only one place for the alkynyl group to be. So I can draw this same compound like this, and we can see that we would still have the alkynyl group on carbon 1. So that is the reason why we do not have to actually number the carbons in this case. In number 12, again we have an alkynyl group, and there are 2 carbons. So we would call this ethyne. Now let's get into some functional groups that are not hydrocarbons. The first one is the hydroxyl group, OH. A compound that has a hydroxyl group is classified as an alcohol. An alcohol has the general formula ROH. R is a hydrocarbon chain, and the name of an alcohol ends with the suffix -ol. Let's look at a few examples. Again, these are in your guided practice packet. In number 13 through 16, we are given the compounds' names and we're going to draw the molecules. So in number 13 we have methanol. Meth means 1 carbon, and tells us that the carbons are all bonded by single bonds, and the ol suffix tells us that this is an alcohol, meaning there is a OH group. So we're going to start by drawing the 1 carbon. Now this 1 carbon is going to have 3 hydrogens bonded to it, and then there's going to be that hydroxyl group, which is what that ol ending tells us. Now that's the full structural formula, and we can also draw this with a condensed structural formula, CH3OH. Number 14, propan-1-ol. Prop means 3 carbons. The "an" tells us that the 3 carbons are all bonded by single bonds, and the ol ending tells us that there's a hydroxyl group. Now the 1 in front of it tells us that the hydroxyl group is attached to carbon 1. Carbon 1 can be the carbon that is furthest to the left or the carbon that's furthest to the right. I usually would put the hydroxyl group on the right. So that is our full structural formula for propan-1-ol. If I draw the condensed structural formula, then it will be CH3, CH2, CH2OH. Number 15, propan-2-ol. Again, we have 3 carbons, all bonded by single bonds. The hydroxyl group is attached to carbon 2, which is the middle carbon. And then we just need to fill in all of the hydrogens for the carbons to complete this structural formula. Notice that propan 1-ol from number 14 and propan 2-ol are structural isomers. And here is the condensed structural formula. Number 16, 2-methyl-butan-2-ol. The prefix but tells us that there are 4 carbons. Again, they're all bonded by single bonds. On carbon 2, there is a methyl group. Now I'm just going to draw this as a CH3. And also on carbon 2 is where the hydroxyl group is. And then we just need to fill in all of the hydrogens for the carbons to complete this structure. Again, I'm going to draw the condensed structural formula as well. So this will be CH3, C, CH3, OH, CH2, CH3. Now go back to number 14, and I want to draw your attention to the carbon that has the hydroxyl group attached to it. I have put an asterisk right next to it. Notice that there's only one other carbon attached to it. This is what we call a primary alcohol. Okay, and we can abbreviate this as 1 with a degree sign for primary. So primary alcohols have one carbon attached to that carbon that has the hydroxyl group. Number 15, we can see that the carbon that has the hydroxyl group attached to it has 2 other carbons attached to it, so that is a secondary alcohol. And we can abbreviate secondary with a 2 with a degree sign. And finally, on number 16, this carbon that has the hydroxyl group attached to it has 3 other carbons bonded to it. So this is a tertiary alcohol. And again, we can abbreviate tertiary with the 3 with a degree sign. The next functional group is the carbonyl group. The carbonyl group is a C double bonded to an O. Now the carbonyl can occur at the end of a compound or in the middle of a carbon chain. If it's at the end of a compound, then we classify the compound as an aldehyde. And the general formula is RCHO. Again, the R is a hydrocarbon chain, and an aldehyde's name ends with the suffix -al. If the carbonyl group occurs in the middle of a carbon chain, then the compound is classified as a ketone. So the general formula would be RCO R', where R is a carbon chain and R' is the other side of the carbon chain. The name of a ketone ends with the suffix -one. We'll look at number 17 through 22 in the guided practice packet next. Number 17 is methanal, also known as formaldehyde. Meth means there's one carbon, and the -al suffix tells us that there's a carbonyl group. So the carbon is bonded with a double bond to an oxygen. Now carbon needs 4 bonds, so it's going to have 2 more bonds with 2 hydrogens, like this. And the condensed structural formula would be CH2O. Number 18, ethanal. Eth means there are 2 carbons bonded by single bond, and the -al ending tells us that this is an aldehyde, so the carbonyl group is at the end of the chain. And to complete this structural formula, we just need to fill in the rest of the hydrogens. The condensed structural formula would be CH3CHO. Number 19, butanal. But means 4 carbons. Again, the and tells us that the 4 carbons are all bonded by single bonds. The al ending tells us that the carbonyl is at the end of the chain. And let's fill in all of the hydrogens. And the condensed structural formula would be CH3, CH2, CH2, CHO. Notice that in aldehydes, carbon 1 is always the carbon that has the carbonyl group attached. Number 20, propanone. The -one ending tells us that there is a carbonyl group in the middle of the hydrocarbon chain. And since there are 3 carbons, the only place where the carbonyl group can be is on carbon 2. Carbon 2 now has 4 bonds, so it will not have any hydrogens attached to it. So to complete this structure, I just need to put the hydrogen atoms on the carbons at the 2 ends. And let's draw the condensed structural formula, CH3, CO, CH3. Number 21, pentan 2-one. Pent means 5 carbons, all bonded by single bonds. Carbonyl group on carbon 2, and now carbon 2 doesn't need any more bonds, so don't attach any hydrogen to it. And to complete this structure, we just need to fill in the hydrogens for the other carbons. And the condensed structural formula would be CH3, CO, CH2, CH2, CH3. We can condense this even further by writing CH3, CO, CH2, 2, CH3. In number 22, we are given a drawn molecule and we need to name it. So the first thing we're going to do is figure out the longest carbon chain. And here it is. Now we're going to number the carbons so that the branches and the functional groups have the lowest numbers. And we have a methyl group and a carbonyl group. And so now we just need to name this. Since there are 5 carbons in the parent chain, this would be a pentanone. The methyl group is on carbon 2, so we'll start there. 2-methyl, pentan, 3-one. The last functional group that we will talk about in this video is the carboxyl group. The carboxyl group is a combination between a carbonyl and a hydroxyl. It always occurs at the end of a carbon chain. And a compound that has the carboxyl group is classified as a carboxylic acid. The general formula for a carboxylic acid is RDOOH. Again, the R is a hydrocarbon chain. And the names of carboxylic acids end with the suffix oic acid. Now we'll look at number 23 and 24 in the guided practice packet. Number 23 is ethanoic acid or vinegar. Eth means there are 2 carbons and they are bonded by a single bond. The ending oic acid means that there's a carboxyl group, drawn like this. This carbon that has the carboxyl group now does not need any more hydrogen attached. So we just need to fill in the hydrogens for the other carbon, and that is the finished structural formula. If we condense this, we would write CH3, COOH. Another name for ethanoic acid is acetic acid, which you may remember from Chemistry 1. And we had written it as HC2H3O2. Number 24, propanoic acid. Prop means 3 carbons attached by single bonds, and the oic acid ending means that there's a carboxyl group at the end, and then we just need to fill in the hydrogens to complete this full structural formula. The condensed structural formula would be CH3, CH2, COOH. Now this video is already getting too long, so we will leave the rest of the functional groups to part 2.